the set that we have in section 2.6, okay, we're looking at polynomial and rational inequalities. And we have for number 1, okay, we're looking at solving for x, whereupon we have x squared minus 10x is greater than or equal to negative 24. And if I rewrite what I have here as a comparison to 0 inequality, all right, so we have upon adding 24 to both sides, so we have that x squared minus 10x plus 24 is greater than or equal to 0. And looking at what we have and just expanding what we have here, okay, so we have upon factoring, okay, we have the quantity of x minus 6 times that of x minus 4 is greater than or equal to 0. All right, so if you were to determine the zeros from this, where we have the expression equal to 0, so we have from x minus 6, so we have that x is equal to 6, and from x minus 4, we have that x is equal to 4. So we have, in the case of our zeros, and I'm just going to rank order the variables in increasing order, so we had the zeros again at 4 and 6. Now, in terms of setting up what we have here, and we have establishing a table, and taking what we have, so just have some headings here. So you have an interval, and starting from negative infinity, approaching 4, but not including 4. And then we have going past 4, approaching 6, but not including 6. And we have for the remainder, since no other 0 exists, so we have going past 6 and heading on out to infinity. All right. And so we have, first of all, okay, we can ascribe, or in this case, insert test values. And we can choose a value at random that is less than 4. We can go with any number, could be 3, 2, 1, 0, anything that is negative. We'll just go with the number 0. Now between 4 and 6, we have only the value 5. And we can select any value greater than 6 to test out, okay, the last of the intervals. So we'll just go with the number 7. Okay, and now, and just for what we have in separating, since we draw these vertical boundaries, and again we have testing out. So again we have when we rewrote the inequality in terms of comparison to 0, okay, we had the trinomial x squared minus 10x plus 24 All right, so testing out the first of the subintervals. Okay, so we have f of 0. So if x is 0, so you have 0 minus 0 plus 24. So you have f of 0 is equal to 24. And in the case of what we have for f of 5, okay, so you have f of 5. Okay, we have, in this case, you have 5 squared is 25, minus 10 times 5, we have negative 50. And 25 minus 50 is negative 25 plus 24, so this will come out to negative 1. And in the case of what we have with f of 7, okay, 7 squared is 49, negative 10 times 7 is negative 70, and got 49 minus 70 is negative 21 plus 24, so this will come out to 3. And I'm going to stress the sign values. Now, looking at what we have at this stage. And we have for the determination of what we have for the sign values. Okay, so I have for the sign of f of x. Okay, so anything we plug in for x that is less than 4, okay, now the result is going to be a positive value. Anything we plug in greater than 4 and less than 6, okay, in this case 5 is a test value, the result is going to be negative. Anything we plug in greater than 6 is going to result as a positive output. So in the case of what we have here, if you had the output to be positive, then you have f of x is greater than 0. And if the output is negative, we have the f of x is less than 0. All right. So for what we have in the case of the comparison to 0 inequality, again, this had condensed to x squared minus 10x plus 24 is greater than or equal to 0. And in this particular case now, we'll be looking at the limits for what we have in the case of starting out where we have the function to be positive. So we have with the limits. Okay, so you have between negative infinity and 4. And since the inequality includes the 0. Now again, infinities are balanced, so they will stay in parentheses. Now we have with 4, since 4 is a 0, and since the inequality is inclusive of the equal to 0 notation, okay, so 4 is going to be enclosed. And then we have for the other subinterval, okay, so you have starting from 6, and since you have equal to 0 in the inequality, okay, 6 is going to be in the bracket, and we have on out to infinity. All right. So in terms of what we're going to have from a graphing standpoint, okay, so you have going from negative infinity approaching and including 4. So if we take what we have here, so we have 4 is included, and then we're going to have going continuously out to the left. Notice you have a value at 6, and then you're going to have an array that will go continuously out to the right, and then checking. Okay, for what we have in the case in number 2, we're looking at the product of 3 binomial expressions to be less than 0. And if we go ahead and identify the zeros of each factor, so you have x at negative 2, x at 4, and x at negative 6. So we have, upon identifying the zeros, and just to rank order from smallest to largest, so we have negative 6, negative 2, and positive 4. Now, and just setting up a table. And again, we have among our intervals, so we have starting from negative infinity, approaching but not including negative 6. And then we have going past negative 6, approaching but not including negative 2. We have going past negative 6 to negative 2, and then we have going past negative 2, approaching but not including 4, and with 4 as the highest 0. So you have going past that and heading on out to infinity. Okay, and again, we're going to insert tested values. Okay. Also, we'll have just for the function values to have f of x. So again, we have the quantity of x plus 2 times that of x minus 4 times that of x plus 6 again, we're looking at the sign of f of x. All right, so we have in forming the table and separating what we have in the case of the rows and the columns. Okay, now for the tested values, we can plug in anything for x that is less than -6, so we can go with -7. Anything between -6 and -2, you might go with -5, -4, or -3. Anything between -2 and 4, you can just go with 0. And anything greater than 4, we can just go with the number 5. Okay, and now, so we have looking at what we have for each of the outputs. Okay, so again, we're not stressing the exact value so much, but in the case of the inputs, they have f of -7. So -7 plus 2 is -5. -7 minus 4 is going to be -11. So you got -5 times -11 is going to be, in this case, positive 55. And then we have times, okay, -1. So f of -7, this will become -55. In the case of -3, -3 plus 2 is -1. -3 minus 4 is -7. -1 times -7 is going to be a positive 7. And then we have times 3. Okay, so we have for f of -3, this will be a positive 21. In the case of what we have with f of 0, okay, so we have 2 times -4 is -8 times 6 is going to be -48. And we have in the case of 5, okay, so we have 5 plus 2 is 7. 7 times 5 minus 4 would be 7 times 1 is 7. And we have 7 times 11, so we have f of 5. It's going to be a positive 77. And okay, so taking what we have now, okay, so we have in the first setting, okay, so we have so having this one, okay, so we have for f of -7 equal to -55. Okay, anything you plug in less than -6, the output is going to be negative. So we have that f of x is going to be less than 0. And then we have for next item, in case you have a positive, so we're going to have the f of x is greater than 0. Then we have next, okay, we have negative sign, so we have the f of x is less than 0. And for what we have in the case of the last interval section, so again, we have anything that we plug in greater than 4, the output is going to be positive. Okay, so we have that f of x is greater than 0. Okay, we have in the solution, okay, where we have to be less than 0, so we have values of x that will be less than -6. And also we have values of x between but not including -2 and 4. So in transferring this bit of information over to what we have in Aleks, checking, and the result is correct. And for what we have here, okay, so you have, again, the product would have to be greater than 0. And if we identify the zeros, so we have with x minus 3, we have x equal to 3. And from x plus 6, I have x equal to -6. And rank ordering the zeros from smallest to largest, or smaller to larger, I have -6 and 3. We have the values of x less than -6. And then we had those values of x between and not including -6 and 3. and we have those values of x greater than 3. And again, just to test out each of the subintervals, okay, we assign a test value x. So for the first subinterval, we're looking at plugging in anything that is less than -6, and -7 would fit the bill. It could be -1,000, -1,000,000, but -7 is sufficient. And we have anything between -6 and 3. 0 will be such a value. And for the last subinterval, which we had to consist of values of x greater than 3, 4 will fit the bill. And taking each of these inputs, so if I have for f of x equal to x minus 3 quantity squared times the quantity of x plus 6, if I plug in -7, the output is a -100. Plugging in 0, you have like -3 squared is 9, and you have times 6. 9 times 6 is 54, and with x at 4, 4 minus 3 is 1, square of 1 is 1, 4 plus 6 is 10, 1 times 10 is positive 10. And for the sign of f of x less than -6, okay, the result is negative, so we have that f of x is less than 0. Anything we plug in between -6 and 3, but not inclusive of -6 or 3, the output will be positive, so we have the f of x is greater than 0, and anything we plug in greater than 3. And so we have here the output is also positive, so we have the f of x is greater than 0. And so for what we have in this particular situation, okay, is that whereupon we have the square of x minus 3 times the quantity of x minus 6 to be greater than 0, we're going to have with the solution, and this will be where we have f of x to be greater than 0. So we have for the first subinterval section, we have -6 to 3, okay, in parentheses, and we have followed by those values of x greater than 3. And so if I relay this on over to what we have here, okay, so we have so you have between -6 and positive 3. And taking what we have this time, the union symbol, and we have going from 3, and we have on out to infinity, and checking, and the result is correct. Okay, for what we have in the case of number 4, okay, we're looking at solving the inequality where we have x plus 1 all over negative x minus 6 is less than 0. And so looking at what we have now, okay, so we have x plus 1 over negative x minus 6 is less than 0. And if I identify the zeros, so we have from the numerator, have x equals to -1. From the denominator, okay, if I make the negative x minus 6, multiply both sides by -1, rewriting where we have x plus 6 is equal to 0, we can easily get to that 0 value at -6. So rank ordering the zeros from smaller to larger, we have -6 and -1. And again, if I have x at -6, the denominator would be 0 in value. And again, for a rational expression to be defined, we cannot have a 0 valued denominator. So -6 is not in the domain, but we're going to use it in the table setup. -1 is in the domain. Now you have, so if x plus 1 is situated where we have x equal to -1, x plus 1 becomes 0, and you can have a 0 numerator as long as you do not have a 0 valued denominator. Okay, so we have, with the interval sections, okay, so you have going from -infinity approaching but not including -6, and we have bypassing -6, nearing but not including -1, and we have bypassing -1 heading on out to an infinity. Now testing each of the subinterval sections, okay, now for the inputs, okay, if I plug in any value less than -6, -7 fits the bill. Anything for x that is greater than -6 and less than -1, -2 would fit such a description. And anything greater than -1, we have 0 as a possible input value. And so plugging each of the quantities, the -7, -2, and 0 into f of x is equal to x plus 1 over -x minus 6. Now we have with -7. Now -7 plus 1 would be -6. Now for the negative of -7, that would be positive 7 minus 6 is going to be 1. And you have -6 over 1 ends up at -6. Now for -2, we have -2 plus 1 is -1. Opposite sign of -2 is going to be positive 2 minus 6 is -4. Negative 1 over -4 comes out to a positive 1 over 4. And for 0, we've got plus 1 over -6. So we have a minus 1/6. Now, for the sign of f of x, okay, first interval section, okay, for values of x less than -6, the output is going to be negative. So we have the f of x will be less than 0. Anything we have in the middle for x, you have a positive output, so we have the f of x is greater than 0. And we have in the last case, all right, so we have any value of x greater than the -1, the output is negative, so we have the f of x is less than 0. Okay, now, in looking at what we have for the inequality, now we have x plus 1 over -x minus 6 is less than 0. And where we have, again, so we have f of x refers to the ratio, where we have to be less than 0. So we have with the results here, so you have values of x that will be less than -6. And then we have values of x that will be greater than -1. Okay, and before I key that into Aleks, let me mention something here regarding what's in the domain and what is not. Okay, now, if you have x plus 1 over -x minus 6 to be not less than, but less than or equal to 0, now you'll be looking at the same limits. Okay, but now the equal sign considers a possibility that you may have brackets in the mix. And brackets will go around finite zeros that will be in the domain of the function. And okay, so we have in this particular case, all right, so we have -6 is not in the domain, not in the domain, and to just indicate in red, not in the domain. -6 is not in the domain, and if a 0 is not in the domain, okay, that is going to be in parentheses. And we have in the case of -1. Now, -1 is in the domain. And for what we have here, since -1 is in the domain, the enclosure around -1 would be a bracket. All right. But going back to what we have with our problem in number 6. Okay, so we have looking at combining what we have here. So we have for the first interval section case, so we have parentheses throughout, and we have with the input, we have going from -infinity, approaching, but not including -6. And we have the other part of the solution, we have going past -1, and we have approaching positive infinity, and checking the result. And the output is correct. For what we have in the case of number 5, okay, we're looking at a comparison inequality between two ratios. And now, so here we have -2 over 7 minus x is greater than or equal to 1 over x plus 1. And if I rewrite this expression as a comparison to 0 inequality, so I can move the 1 over x plus 1 over by subtracting. And what I can do is I can just rewrite this comparison statement. If you notice, I have -2 over 7 minus x. Now, you can leave this ratio as it is, but I thought it would look a little bit more user-friendly. And if I just multiply by 1, the form of -1 over itself, we had translating to where we have the x term in the denominator is positive, and where the constant will be the negative. And we have, so multiplying by -1 over -1, we have 2 over x minus 7. And we have in the rewrite, so we have 2 over x minus 7. And we have -1 over x plus 1 is greater than or equal to 0. And if I consolidate what I have here as a combined rational expression, so joining together, we have 2 over x minus 7 minus 1 over x plus 1. Now the least common denominator, we had the quantity of x minus 7 times that of x plus 1, and multiplying by 1 in the form of the missing factor from the least common denominator divided by itself. So we have a 2 over x minus 7. We got the x minus 7, but missing the x plus 1. For 1 over x plus 1, we're missing the x minus 7. So applying the treatment, we have, and combining the terms, okay, so you have distribution, you have 2x plus 2. Now we're going to be distributing subtraction over the second ratio numerator. So we have the quantity of x minus 7 that will be subtracted over, and combining what we have here. So we have negative x plus 7, and joining with 2x plus 2, we have x plus 9 all over the quantity of x minus 7 times that of x plus 1. And we have, with the zeros from the numerator, I have x equal to negative 9, and you can have a 0 numerator as long as you do not have a 0 denominator. So negative 9 is in the domain. Whereas in case of 7 and negative 1, those stem from denominator factors. They are zeros, but they are zeros that are not in the domain. Okay, and we have, in setting up a table, so we have as an input value for the first interval, we have negative 10, and then we have negative 2 for the second interval, 0, since we have 0 to lie between negative 1 and 7, and 8 can be chosen, okay, for the last interval test amount. Okay, and we have plugging in each of the values into f of x equal to the ratio x plus 9 divided by the product of x minus 7 and x plus 1. So we have f of negative 10 is negative 1 over 153, and the sign of f of x is going to be negative. So we have here that f of x is less than 0. And then we have next, okay, we have with negative 2, the result we have to be a positive 7/9. So here we have that f of x is going to be greater than 0. And then we have next, okay, we have for the third subinterval, output is going to be negative. So we have the f of x is less than 0. And for the fourth subinterval, okay, we're going to have positive output. Whereupon we're going to have the f of x is greater than 0. Okay. All right, so looking at what we have now. Okay, so we have, again, start out with our inequality and just put it in condensed form. And where we have that essentially f of x will be greater than or equal to 0. So we have, looking at starting out with where f of x is greater than 0, we have the limits. So we have negative 9. And negative 1, and where we have f of x be greater than 0, we have involving 7 and an infinity. And now for the enclosures, I'll use a little bit of color coding. Okay, so negative 9 is in the domain, and since that the equal sign, okay, that includes the possibility of brackets along with parentheses. So negative 9 is in the domain. Any 0 that is in the domain, we can bracket. And anything that is not in the domain, okay, we leave in the parentheses. Okay, so we have negative 1 is going to be in parentheses as well as 7. And again, infinity is boundless, so that is going to be in the parentheses as well. Okay, so we have testing out what we have here, and had a little bit of a keystroke error earlier. Okay, so I had it incorrect. And now, so we have just for this inequality, so we have, again, we have going, okay, so we have it closed at negative 9. We have to negative 1, and then we have the other portion was going past 7 on out to infinity. And just checking the result. And the result is correct.